All right, welcome back, everyone. Today we're going to talk about factoring polynomials. So in this section, you're going to learn how to factor trinomials. This section will be entirely about this one particular idea. As seen in previous sections, a trinomial is just a polynomial with three terms. Most often when we refer to a trinomial, we imply something of the form ax squared plus bx plus c. That's not how it has to be, but that is, in general, what the form will look like. Factoring just takes the trinomial and turns it into a product of two linear factors. So think about the FOIL method we use to multiply, but in reverse. We're taking the answer and breaking it apart into the things you would multiply together. Now, not every trinomial can be factored, but we can use the same method for the ones that can be factored. And that's what we're going to work on for the rest of this lesson. And so we're going to start out with a simple example. We want to factor x squared plus 7x plus 12. And so I just want you to follow along with this particular method. X squared, the number in front, if there's nothing there, is assumed to be 1. And so what we're going to do is we're going to take the first number and the last number, and we're going to multiply them together. 1 times 12 is 12. And then below this, make a box. And what you write in the box is particularly important. We're going to write this coefficient in front both times, 1 and 1. And then we're going to split this variable up, x and x. And now for the bottom two parts of the box, we're going to need two numbers that multiply to give you 12 and add to give you 7. And so two numbers that multiply to give you 12 and add to give you 7 are 4 and 3. And so at this point, we're essentially done. In later problems, there'll be an extra step here. But because those coefficients of x, because that coefficient of x in the front is 1, then we don't have any additional steps here. And the factored form is just 1x plus 4, or x plus 4, and x plus 3. Each side of the box represents one of the solutions. And so here's our factored form of x squared plus 7x plus 12. If you want to check your answer, FOIL those things, and you should get back what you started with. So we're just going to keep practicing this method. Again, the number in front is understood to be 1. And so we're going to take the first number and the last number and multiply them together. 1 times 35 is 35. We're going to make a box. Write the coefficient both times and split the variable up, x and x. Now we need two numbers that multiply to give you 35 and add to give you negative 12. Well, negative 7 and negative 5 will both multiply to give you positive 35, and if you add them together, you get negative 12. And so our factored form is x minus 7 and x minus 5. Okay, let's keep going. A squared plus 2a plus 10. Again, we're going to take the first number and the last number, multiply them together, make ourselves a box. 1a, 1a. And now we need two numbers that multiply to give you 10 and add to give you 2. Well, the only numbers that multiply to give you 10 are 10 and 1 and 2 times 5. And neither of those pairs add to give you 2. So there's nothing else we can do here. We can't factor this. This trinomial is not factorable. And so because it's not factorable, we say that it's prime. And now we need two numbers that multiply to give you 10 and add to give you 2. Well, the only numbers that multiply to give you 10 are 10 and 1 and 2 times 5. And neither of those pairs add to give you 2. So there's nothing else we can do here. We can't factor this. This trinomial is not factorable. And so because it's not factorable, we say that it's prime. Same process, except this is going to be just a barely different. Understood 1 in front. 1 times 6 is 6. We're going to make ourselves a box, write the coefficient both times, and split the variable up. Now, the main difference here is that y squared at the end. And to account for the y squared, you just want to write y in the bottom part of the box. Y and y. And now we still need to figure out the numbers in the same way. So we need two numbers that multiply to give you 6 and add to give you 5. Well, 2 and 3 multiply to give you 6 and add to give you 5. And so our solution here, x plus 2y and x plus 3y. So sometimes it's beneficial to remove the greatest common factor first. And so in this case, we have 3m squared minus 24m minus 60. Well, they're all divisible by 3, so we can take the 3 out. And we're left with m squared. 24 divided by 3 is 8m. And 60 divided by 3 is 20. And now we need to keep the greatest common factor around because it's going to be part of the answer. But now we just need to factor the thing within the parentheses. So again, take the first number and the last number and multiply them together. That'll give you negative 20. We're going to make a box, write the coefficient both times, and split the variable up. Now we need two numbers that multiply to give you negative 20 and add to give you negative 8. Well, negative 10 and positive 2 will add to give you negative 8 and multiply to give you negative 20. And so what we get from this part is m minus 10 and m plus 2. And then just remember to bring down the greatest common factor. We want to do the same thing here. In this case, we have 2x to the fourth, 26x cubed, and 84x squared. All of them are divisible by 2x squared, so we can factor that out. And you're left with x squared minus 13x plus 42. So once again, we want to keep the greatest common factor around, but we only need to factor what's in the parentheses. So 1 times 42 is 42. And now we need two numbers that multiply to give you 42 and add to give you negative 13. And so negative 6 and negative 7. Those two numbers multiply to give you 42 and add to give negative 13. And so from this part, we get x minus 6 and x minus 7. And then we just got to bring the 2x squared down. So one of the hardest parts of these problems is just figuring out what numbers to put in the bottom two boxes. Right? Just keep trying numbers until you find the ones that work. If you run through every possible combination that would multiply to give you 42, and you can't find any numbers that will work to add to give you negative 13, right, then there's a possibility that the polynomial is prime, as we saw a few examples ago. Not every trinomial can be factored. Now, if the trinomial begins with a number, right, so the coefficient of x squared is no longer 1, we can still use the same method. So 3x squared plus 11x plus 6. There's going to be one small difference towards the end. Take the first number and the last number and multiply them together. 3 times 6 is 18. So we're going to make ourselves a box, write the coefficient both times, and then split the variable up. We now need two numbers to multiply to give you 18 and add to give you 11. And so 9 and 2. And now because the first number is no longer a 1, there's one more step to be done here. Each side of the box will reduce like a fraction. They're not fractions, but they'll reduce like 1. In such a way that 3 will go into 3 and 9. So 3 divided by 3 is 1, and 9 divided by 3 is 3. On the right-hand side, there's nothing that will divide into both 3 and 2. And so we get x plus 3 and 3x plus 2. So if that first term is not a 1 and you want to use this method, make sure that when you get down to the box, each side will not reduce. And remember that you can always go back and check your answer by multiplying. So here for this example, we can use the same method. We're going to take the first number and the last number and multiply them together. 8 times 5 is 40. And now we're going to make ourselves a box and write the coefficient both times, 8 and 8. And split the variable, x and x. Now we need two numbers that multiply to give you 40 and add to give you negative 22. Well, negative 20 and negative 2, both of those will work. They multiply to give you positive 40 and add to give you negative 22. But now remember, we have to reduce each side like a fraction. So 4 will go into 8 2 times, and it'll go into 25 times. And 2 will go into 8 4 times, and it'll go into 2 1 time. And so what we're left with is 2x minus 5 and 4x minus 1. If you multiply that back, you should get what you started with, 8x squared minus 22x plus 5. Here we're going to do a similar thing, except remember that now there's a y squared at the end, so we'll have to account for that. 10 times 3 is negative 30. And so we make ourselves a box, 10x and 10x, and we're just going to write the y's down at the bottom. And now we need two numbers that multiply to give you negative 30 and add to give you negative 13. And so two numbers that multiply to give you negative 30 and add to give you negative 13 will be negative 15 and positive 2. And now again, we can reduce each side like a fraction. So 5 will go into 10 2 times, and it'll go into 15 3 times. 2 will go into 10 5 times, and it'll go into 2 once. And so we get 2x minus 3y and 5x plus 1y, or just plus y. Now we want to factor by first removing the greatest common factor. In this case, all of the terms are divisible by 2 and divisible by x squared. So we're going to factor out a 2x squared. And what we're left with is 12x squared plus 20x plus 3. And now we can factor what's inside the parentheses. 12 times 3 is 36. And so we're going to make ourselves a box. 12x and 12x. We now need two numbers that multiply to give you 36 and add to give you 20. So 18 and 2. And again, we can reduce each side like a fraction. 6 will go into 12 2 times. It'll go into 18 3 times. 2 will go into 12 6 times, and it'll go into 2 1 time. And so we're going to bring down the 2x squared. And then what we're left with is 2x plus 3 and 6x plus 1. So at the end of this lesson, you should be able to factor trinomials.